This short presentation is around factorising expressions, algebraic expressions. So it's the reverse process of binomial expansion and the distributive law. What we're going to do is apply our knowledge of factors to simplify equations and reverse that process that we looked at previously. So factorising is the opposite of expanding expressions, and we're looking for the highest common factor of each term. Factors, you may recall, are the numbers that multiply to give another larger number. For instance, 3 and 2 are factors of 6, as are 6 and 1. So what we're looking for is just going through and finding the highest common factor. So the easiest way to do that is to list out the factors until you become proficient or are able to do it in your head. So we'll start with this first example, 12, 16 and 56. Now we should be able to identify that all of those are even numbers, so 2 would be a factor. But is it the highest common factor? So let's look at the factor pairs for each number. So we have 12. For 12 we have 1 times 12, 2 times 6 and 3 times 4. They're all the factor pairs of 12. For 16 it's 1 times 16, 2 times 8 and 4 times 4. And already we can start to see some common pairs there. And 56 is 1 times 56, 2 times 28, 4 times 14 and 7 times 8. So the biggest factor that is common to all of them is 4. So the highest common factor is 4. For algebraic examples, we need to consider both the pronumerals and the number coefficient. So let's start with those. B is a common factor to both terms, so that means it is part of the highest common factor. C is also a common factor, hence BC is part of the highest common factor. And then consider the numeric values. 4 and 6 have a highest common factor of 2. So the highest common factor when you put those three things together is 2BC. So we're going to take that to the next step, which is factorising. Once you know your highest common factor, we then divide each term to work out what goes in the bracket essentially. So here's our first example, 5x plus 15y. There are no common pronumerals, so it's just the number coefficient part that we're looking for. And most of us could probably recognise that 5 is a prime number, so it's only got one factor pair, 1 times 5. And because 15 ends in a 5, it also has a factor of 5. So no common pronumerals, highest common factor of 5 and 15 is 5. So we divide each of those terms by 5, and we get 5x divided by 5 is x inside the bracket, 15 divided by 5 is 3, y stays in the bracket, because we didn't take any pronumerals out. So 5 outside of x plus 3y is the factorised version. Let's go back a step. We can actually check that using the distributive law. So 5 times x plus 5 times 3y equals 5x plus 15y. And that's because they're the inverse operations of each other. They cancel out. Here's a second example. This one has pronumerals as well as numeric values. So let's look at the pronumerals first. Y is a common factor to both, so that means part of the highest common factor. The highest common factor of negative 14 and negative 7, remember the negative stays with the coefficient, is negative 7. And as much as possible we want to remove those negative values where we can. So we divide by negative 7y. So negative 14 divided by negative 7 is 2. Negative 7 divided by negative 7 is 1. Y comes out of this one, leaving with just the x pronumeral. And y comes out of this one, leaving us with no pronumerals left, because y divided by y is 1. Once again, you can check by applying the distributive law. This one here's got 3 terms, so it's a little bit more complex. But it's the same process. What letters or pronumerals are common to all 3? The B. That's the only common pronumeral. Then we look at the numeric coefficients. 15, negative 21 and 18. They're all multiples of 3, so 3 is the common factor. We divide by 3b. So here it is here, 3b out the front. Take the b out here, we're left with a in the bracket. 15 divided by 3 is 5. Negative 21 divided by 3 is negative 7. The b comes out as a common factor, we're left with c. 18 divided by 3 is 6, and we take the b out as a common factor, leaving us with f. So there's your answer there. 3b outside of 5a takes 7c plus 6f. Okay, now we're looking at some with powers, so that makes things a little bit more complex, but it's just reversing your index laws. Same process though. What letters are common to both? X and y are common factors, not x squared. So x squared is not a common factor because we've only got one x here. Remember, x squared means x times x. So only one x is common. Same with the y's. So xy is a factor of both. And then we look at the coefficients, 6 and 9. The common factor is 3, so we're going to divide each of the 6 and 9 by 3. So our highest common factor in this particular case is 3 x y. So we divide 3 by that. There's our common factor at the front. So 6 divided by 3 is 2. 9 divided by 3 is 3. We take out one of the x's and one of the y's, leaving us with one x inside the bracket. So we cancel. If you like, we'll look at it like this. X, y, so that x cancels with that. The y cancels with that. We're left with just the x. Same over here. X, y. That's what we're dividing by. So the x's cancel. The square cancels with that y. So that results in 3xy outside of 2x plus 3y. So that's how we factorize, and that's a skill that you looked at least initially last year.